So class was pretty wild today, and there was a number of people gone. So here's a review of what we did. So in class, we had this whole swing set problem that we were looking at. And at the beginning of class, we decided via a percentage change, if you double an input, that the length is what matters most. Then we took a lot of good data in this Google form. And after we took all that good data, the results were here. So we have something like, maybe 70 records from all these different people. We only had to make one correction in the sheet with regard to measuring in inches instead of centimeters. So now we want to look at the data, and that's easiest done if you download it. So File, Download as Microsoft Excel. So you can just save that. Once it's downloaded, we can start making plots to see what kind of relationships we can find. So here's the data. Let's see. I'm going to make it a little bit smaller, and I'm going to delete these two columns. All right. So here's all the data. And so our goal is to try and find relationships in this data so that we can figure out what's going on. Just a minute. Okay, so there we go. Plenty of room to work. So the idea was, if you change the string length, the time for one swing would change. So time is my output variable, so I'm going to highlight all of the values. I did that by doing Shift Control down. I'm going to insert an XY scatter graph, and I don't know why it doesn't paste up at the top. It's kind of sad. So there's my XY scatter graph. I want to right-click, select data, edit the series, and pick out the X values I want. I think that string length is what predicts it. So I'm going to hit return. And then, okay. There's my graph. Now, I've got to label it so that I know what's going on. And I think that's up here somewhere. I guess the easy way to do it would be to add some axes. Why didn't they add, I wonder? Titles, that's why. So pretty sure that this axis right here is length in centimeters. Pretty sure this axis here is time in seconds. Okay, so we've got this data, and then you remember, once we've got a graph, we see if we can describe that data with a model. So we add a trend line. The linear trend line was our first choice, and remember, we always want to see what the equation is. So we've got this linear trend line, and it looks like it goes through the data mostly. In class, we talked about how this is broken, because if you go to no length, I think I spelled this wrong. If you go to no length, you still have half a second of swing time. That doesn't make any sense. So we can go to the trend line, and we can nail the intercept down to 0. It changes our slope a little bit. It doesn't fit as awesome, but at least now the 0, 0 point is something we can believe in. So now you've got this math model, and the output part is time in seconds, and the input part is length in centimeters, and this number 0.326, what does that mean? Well, how about seconds divided by centimeters. Because if we multiply by a centimeter, the centimeters on the bottom divides out, and then we have seconds and seconds. So that's my math model. Now, I want to remind you that we did all that work, and then we took another data point. So let me add that other data point in. So we added one more data point, and the x value was 200 centimeters, and the y value was 2.8 seconds. This was when we attached the string to the conduit at the top of the classroom. So that's this orange point. So the straight line predicts a time of like 6 seconds up here. Didn't happen. What we got was 2.8. So then in class we had this discussion, what kind of line is curvy and goes through all the data? Some people said exponential, some people said logarithmic, right? There are a lot of different ideas. One of the ideas you could say is that this looks like a square root function, right? Like maybe the square root of time looks like length. Maybe. So just a minute. All right, so maybe before you put the square root function in to see if that actually works, we can go to Google. I don't know if you know this, but Google can plot things. So plot the square root of x. Let's try that. So it's actually a graphing calculator, Google. And if you zoom out to bigger oh no, I don't want to do that. If you zoom out to bigger numbers, you see you can change the way it curves over. But this curving over, maybe that curving over reminds you of what the data does. Maybe. I wonder if I can make this smaller so that we can compare them side by side. So maybe this curving over for square root x looks like how the data curves over. So maybe that's an idea you want to try. Okay, so if we think that time is equal to the square root of x, that would be the square root of length. That means we need to make a column called the SQRT of length. So that's going to be the name of this column. And then inside of this column, I'm going to say that this cell equals the square root of wherever the length is, right there. So you notice I'm just typing out that formula. And if I want to check if the reference is okay, I can just click here. You see that I'm doing the square root of this B2 cell, so B2. So once I've got that, I can just Control-C copy, go to the bottom of this column, go to the top of this column, Control-V paste. So now I've got this column, the square root of length. So here's a quick trick for making plots. If we select a plot, we can copy and paste, right? That's pretty nice. And then if you click on the data points, see how you got purple and blue? So I've got length on the x. I think I want square root on the length on the x. And if you do this the right way, I feel like you get a hand. No, it's not that one. Well, on a Mac, you get a hand. On a Windows, you get an arrow with an arrow. And look at that. All the data changed. Let's get rid of this outlier. No, that's not the outlier. That's just that point way out there. Look what happened. Before, the data curved, and it didn't quite do what we wanted. The data didn't quite do what we wanted. The line, the curve, they didn't line up. Now, the data and the line, they're still spread in our measurement, but it's a straight line relationship. And I just want to remind you, this is not length now. It's the square root of length. And so that means that this unit is actually centimeters to the, 0.5 power. Remember how you can write powers as fractions? So that's my relationship. So that means I need to change my math model. I'm going to get rid of this and display this trend line equation. And then I'm going to modify it and say time in seconds is 0.2, whatever, sqrt of length. And then the units of this slope, 0.21, they're going to have to be seconds divided by square root centimeters, which probably sounds like a crazy unit, but look, you're going to plug in like 100 centimeters and take the square root of that 100 centimeters here. And that means that we have to divide out the square root of centimeters right there. So this is one way of describing that math model. The other way in class we talked about was that maybe time squared was proportional to length. So that's probably the graph you have. But, you know, math it allows you to say things in a lot of different ways. So one more thing, I forgot to include that last data point. So let me go over, go to the bottom. Remember, we had one last string length, which was 200 centimeters, and that took 2.88 seconds. So if we talk about this data set right here, if we drag down one, we can include that last point. And look at how that last point lines up with the trend. It's a pretty strong contrast when you compare it to this other data set right here, right, where it was curvy and this orange point really didn't make sense at all. Here, this is the orange point, but it's not orange. See how much nicer it is? So, reminder, the homework is to do this for the squared version of the relationship and then predict for a pendulum that is 10 meters long, how long is that swinging time? That is your goal. So use this math model. It won't look like this. It'll be different. But for a 10-meter long swing set, how long will that swinging time be? That's the homework for Friday. All right, that's it.